I recently participated in the Metaculus AI forecasting competition. This involved using large language models to make predictions about politics, business, and technology. In this video, I'll explain how LLMs compare to humans in terms of forecasting performance and how to build your own simple prediction bot. Just by using LLMs to make predictions gives useful insights into their limitations and also helps you to improve at prompting. I'll go through a few things. I'll start off by showing you this competition, which you can enter. Actually, the fourth quarter is just opening up for the first questions today. It's not too late to enter. Then I'll show you a quick demo in ChatGPT of how you can use an LLM to forecast. Next, I'll go through a paper led by Danny Halawi of Berkeley, and it covers forecasting of humans versus LLMs, and it's got a few interesting insights I want to show you there. Then I'll discuss a few advanced techniques going beyond my simple demo before rolling through a notebook demo specifically for the Metaculus competition. That's if you're interested in participating by yourself. And then last of all, I'll give a few caveats for practical decision making. So let's head to the Metaculus competition page. This is the Q3 competition, and you can see that there were a total of 55 bots that entered. I managed to come in 7th place here, although I was beaten by one of Metaculus's own bots here. So you'd expect there is quite a bit of randomness here. They try to make a lot of questions. They try to test you on a lot of questions in order to dampen that down, but there remains a lot of noise in evaluating the performance of bots against each other or against humans. Let's take a look at some of the questions. So the way this works is there will be a series of questions over a period of 3 months. Maybe 400 different questions, and they'll be spread out over time. And you'll have a deadline for each question by which you have to submit your prediction. And the predictions are all submitted, at least in Q3, as a percentage. So it's a percentage that an event will either happen or will not happen. And once the deadline passes for the prediction, you wait until the event actually happens or doesn't happen, which is called the resolution date. And the event will either happen or won't happen, and your percentage score will be compared to that and compared to the estimates of the other competitors to give you a peer score, which will eventually lead to your ranking. Now let's take a quick look at one of the questions here from Q3, and we can see my prediction on it. So for example, before October 1st, 2024, will any of these prominent Democrats appear as guests on the Lex Fridman show? And you can see that my guess, if I go down to the comments, the private comments, looks like I made a prediction of 15%. And this question did resolve as no. So I would have scored fairly well on this because my prediction was fairly low. And up here you can see my baseline score and my peer score is positive because it seems like I did better than other people on that question. So we can look at another question here. Will any of these large tech companies lay off before October 1st? And you can check my bid here was 70%. And it looks like I did better than my peers again in this question, even though this ultimately did not happen. So 70% was a pretty bad estimate. It seems like relative to others, I probably guessed somewhat well on this question. So how do you use a large language model to make a prediction? Well, let's take a quick look by chatting with ChatGPT. So a first question we can ask here is who, we can say, for example, will the winner of the 2024 US presidential election be a Democrat? Respond with your reasoning followed by your final answer in this form. So we wanted to just reasoning, and let's just say your reasoning. So I'm using some chain of thought here, and then prediction, and let's say percentage, something like this here. And we can fix this word here and increase the screen size. Okay. So let's try this question here. It's refusing to answer because it doesn't have the answer. So we're going to say, you are an expert in event forecasting and will help me with this question. Okay, so you can see we have an answer here, and the answer is recognizing that Joe Biden is the incumbent, and it thinks Joe Biden is going to be still running for the election at the current time. And that's because the language model has got a history cutoff that is prior to any information about the presidential candidate changing for the Democratic Party. So we need to improve on our answer here. And the way we do that is by including some search. So we do some retrieval and inject that information into the question. So now we're going to say, you may make use of the following news. So I'll feed in some news here, just between XML tags, and I'll put in a Google search. So I've done a Google search here for United States presidential election, and I've picked this website here from Ireland, breakingnews.ie, and I'm just going to copy some of this information. Now, of course, you could be much more broad and also deep on the information you provide, but let's just give that information and see how it performs. Okay, so here it's putting in the 55% chance, and there's one more improvement that we can make as well. We can do a search potentially of some prediction markets. So we could look at, say, Polymarket, and we can see here, if we just copy in some of these results from Polymarket, and this is a very naive way of showing you how to search. So here you make it the following news, and we'll say you may make use of the following prediction market results. So I've pasted that in very naively, and we'll see what it comes up with. So in this question here, obviously there is a prediction market that matches this. So that's going to provide very raw and useful, well, very not raw, directly useful information for making this prediction. In many other questions, there might be a kind of relevant prediction market, like maybe there's a question on SpaceX and when it will make it into orbit with, say, with the Starship, and maybe there's not directly a market on that, but there's some other markets on SpaceX doing other things. Then you can get relevant information that's useful. Whereas here, there's very directly relevant information which should help improve the quality of the response. So now you can see it's modified the chance that a Democrat will win the 24 election because it's factoring in some of the prediction markets here. And note that I'm running here with the standard ChatGPT settings, which I think probably have got temperature of 1. So there's some variance here. If I just reran this multiple times, I would get different numbers down here as to what the result of this is going to be. So that's a very basic explanation of how you can build a prediction bot, and I will show some advanced techniques later. But first, I want to look at some of the learnings from the Berkeley forecasting paper, which is led by Danny Hilawi. And there are two or three conclusions I want to show in the graphs. So the first thing is that these bots, compared to humans, if you get an ensemble of humans and an ensemble of bots, the bots are quite close. They're not quite as good on some different metrics of accuracy, but they are reasonably close. Bots tend to hedge more than humans. I'll show you the graph, but basically they will often predict more towards the middle, like 30 to 70%, and be reluctant to predict 100% or 0%. And bots tend to actually outperform humans in these events that are less certain, so in the 30 to 70% range, but they tend to be worse in extreme events where we know for sure something is happening or not going to happen. So in the Hilawi paper, and I should maximize my screen here, they use a system of retrieval where they'll take a question, they'll generate some search queries, and use those search queries to find news in a news API, kind of like what I did, but automated. Then they'll take out news articles, rate the relevance, and filter the relevant ones, and then create summaries of that news. And then those summaries are injected with the question into a language model or a fine-tuned language model to generate reasoning or predictions and get a final forecast. So that's the rough pipeline. And they compare performance versus humans, which is called crowd. And ours is, in their case, using their AI system. And there are a few different markets they look at. So they look at Metaculus, which is the competition I entered. They also, I'm not familiar with GJ Open or Infer. They look at Polymarket, which is a betting market, and Manifold, which is a betting market, although not with real money, although I believe there's sweepstakes now. So the accuracy, and accuracy is measured just by comparing the percentage prediction to the actual outcome. So if you predicted 70% and it was the event happened, then you would get a score of 1 accuracy. If you predicted 30% and the event didn't happen, you would also score 1. So it's very naive as an approach, and definitely statistically, it's worth being questioning. But if you take that as some measure of performance, you can see here on Metaculus, humans are outperforming, getting higher accuracy. You can see this is true for all of the other markets as well, except for infer. And I'm not familiar with infer, so I can't really say much more on that one here. Notice that the variance is actually very high. So statistically, these are actually within 1 standard deviation of each other. Meanwhile, on polymarket and on manifold, there's a difference that's larger than the standard deviation there. So basically, humans are not quite as good, at least back in early 2024, but they are not too far off either. And the way in which humans are a little bit worse is primarily at these extreme events. So if you look at the predictions, the distribution of predictions, so they're bucketed here for AI, which is noted ours, and then crowd, which is the humans. And you can see that humans do predict these extreme probabilities. So they'll predict that something is not happening, like in the 0 to 5% range. And they'll also predict more up towards the going to happen for sure range. Whereas if you look at AI, it tends not to predict so much in these extremities and tends to hedge more by giving these kind of more medium type probabilities. And what emerges from the results and is consistent with this graph here is that you can find cases where language models are better at predicting than humans when you are in this intermediate zone of probabilities, 0.3 to 0.7, like 30 to 70%, but then are significantly worse when you move out to these extremities. And the nature of forecasting is that as you get towards the resolution date, so if you say, does event X happen by the end of November, and it's almost the end of November, well, there's little time for the result to change. And so you end up being more confident either that something will happen or won't, which drives you to the extremities. And so language models, as they approach the resolution date, will tend to be worse because they're worse at doing these extreme type predictions. They're better at these kind of hedged predictions. And here the retrieval index corresponds to how close you are to the resolution of the question. So as you retrieve later, the language model has more of a gap with human evaluators, whereas as you retrieve earlier, when there's more uncertainty, the language model performs better. So based on this and just other learnings from messing around and just reading from others who have entered the tournaments, there are a few different tips. One is actually related to that question of when resolution happens. Is it soon or is it far? And this relates to volatility, because if you have more time until something resolves, that means that the result can change. And if the result can change, it'll kind of tend towards being 50%. So a good example is if will Apple be the largest stock by market cap tomorrow? Well, that's almost certain because its market cap is the largest today. But will it be the largest by market cap in 1 year's time? That's a lot less clear because, well, there's a lot of time and a lot of things could change by then. So one of the approaches is you could try have the bot consider the time to resolution just by asking it to state how much time is left before this question resolves, and how would you make your prediction if it resolves at that time, or how would you make a prediction if it resolved in a year, or how would you make a prediction if it resolved before that time. And by having it consider the different time horizons, the bot is able to better consider the kind of volatility and better calibrate its prediction. The second, and you'll think this is obvious, the second way to improve your bot is to do wider data sourcing. If you look at the notebook we'll show later, or I'll show later, it uses Ask News and also Perplexity, but you can also pull in other data. I pulled in data from Kagi, which is also kind of providing news or information aggregation. Putting in prediction markets is also probably a good idea, because that information, if you hit on a question that exactly matches a prediction market that exists, you have very, very relevant information. So obviously that's going to improve your prediction. So ideally you put in a combination of all of these sources. And this is like how a human would try to gather information, trying to consider the breadth of sources and filter that down to what's most relevant. A third technique is extremizing. This is trying to combat the fact that the bots do not predict very well these extreme events. So what you can do is manually extremize. For example, if the bot predicts 30, you can just make it 20. If it predicts 70, you can make it 80. Have some simple linear or exponential or logarithmic rule. I'm not saying it's straightforward to do though. Maybe somebody will figure out a better way to extremize or just to avoid the bot in the first place, making predictions that tend to be too hedged. So before I go and show you the demo for Metaculus, I'll just mention a few caveats here that what I'm talking about is all probabilities. It's will something happen or will something not happen? And in practical situations, you need to consider not just probabilities, but also payoffs or outcomes. So for example, in engineering, you may not even care that much about probabilities. If there's a mode by which the wing could fall off the airplane, well, you're going to pay attention to that as a bad outcome and rectify it, whether the probability is 0.1 or 0.001. And so, yeah, in practice, you need more than what I'm talking about today, which is all probabilities. You also need the payoffs and outcomes. And furthermore, when I talk about scoring, I'm talking about scoring purely in a probability space, whereas in practical applications, you would have to talk about it in a payoff space. Now, you could actually do that if you're looking at betting markets, because the probability there is both the probability and the payoff if you make a bet. But you would need to run through that analysis to figure out whether your bot is actually making money or not. And that's not something I've seen a comprehensive study on yet. What I've looked at to date is all probability focused, and the Metaculus tournament is also all probability focused. So let's take a look at a notebook for entering this competition, and it'll give you a more detailed look at how these prompts are set up. I'll put a link to this collab notebook below. It's just a copy of the notebook provided by Metaculus, but it's got a modification that allows you to directly use your OpenAI key. Otherwise, you have to query via Metaculus, which requires some pre-approval. So we start off and pip install OpenAI and ask news, because we're going to use that in order to fetch the news. I'm going to go to my secrets here and turn on a few. So I'm going to need my Ask News client secret. So I've had to create an account over at asknews.app and put in my client key and also my secret. Then I need to put in my Metaculus token, which I can get from going to Metaculus and then going to settings, and down at the bottom of the page, I won't expose it, I put in my Metaculus token. And furthermore, I'll put in an OpenAI API key and a Perplexity key here. Perplexity will allow me to do some search. So I've enabled all of those, and I'm going to load all of this. Now I'm going to set direct OpenAI to true, which means I'm going to directly query OpenAI rather than going through Metaculus. I believe the intention was to allow querying Metaculus to save people having to put in their OpenAI key. So that probably will work. So maybe if you check this video a few days or weeks after I show this, you won't need to do this. But for now, I'm putting in my OpenAI key. Now here's the prompt. You're a professional forecaster interviewing for a job. Let's increase my size. Your interview question is titled. This is just the title of the question. Background is the background information Metaculus gives. Resolution criteria tells you in which case it will resolve to true or in which case it will resolve to false. Pretty important to have that there so the language model understands. And then any fine print if there's any technicalities around how the resolution would be determined. Then we put in the summary report, which will be generated from Ask News and Perplexity. Then we put in today's date. That's very important. ChatGPT will inject that in the background. So ChatGPT always has today's date, or should. But if you're just querying an API, it won't know the date. So you need to tell it the date so it knows how much time is left until resolution. And here is an attempt to have the model think about this question of volatility. So think about the time left until the outcome. What outcome would happen if nothing changed? What would you forecast if there was only a quarter of the time left and if there was 4x left? Then write your rationale and write your final answer like this. So then there are a few helper functions. This is just for posting a comment on Metaculus. This is for posting your prediction. So you have to submit your prediction as a percentage. It's actually as a fraction, so 0.3, 0.7. Here's a function to get the question details. This is to get the background, the fine print, the resolution criteria. This is a function just to show the questions. And here is a call to Perplexity. So Perplexity have a model called Llama 3.1 Sonar Large. They may actually have an updated model since then, I need to check. But the prompt we give in is you're an assistant to a super forecaster. They'll give you a question and what they intend to forecast on, and you generate a concise but detailed rundown of the most relevant news. And Perplexity in the background will query its sources of news data and pull that into an answer containing the news. Now, the Ask News request is a little bit more involved. You can do a request for the latest news and get the 5 closest articles. You can also look at the historical news and maybe pull in 20 articles. So in this approach, we're actually going to do both. We're going to pull in a stringified version of the latest news and the historical news, and we're going to provide that back. So you can see the return value is the articles with the full context and the formatted articles. And the formatting function here is just putting them in a better format for when they're going to be posted as part of a summary. This is a simple regex, regular expression function to pull out the percentage so we can submit. And then lastly, we've got this important function, getGPT prediction. So you can see here, it's going to assemble content. It's going to pull together the prompt that I showed you up above, but it will inject the title, the date, the background, resolution criteria, fine print, and the summary report. Notice here that the summary report is coming from the formatted articles, which are coming from Get Ask News. And if we want to add in Perplexity as well, we can just add in the summary report from Call Perplexity like this. So we can run those cells. And once we do have that content, I should mention, if we are using direct OpenAI, we're just going to directly call OpenAI with a request to GPT-4o. And we'll use a temperature of 0, although maybe 0.1 or 0.25 would be better. And alternatively, if we're going through Metaculus, we'll do a post request to their API, and that requires permission in order to be able to do it. So here I'll just list the open questions. It's early in the tournament. There's only one real question open, which is, will Tim Walz cease to be Kamala Harris' running mate before November 1st? And then there are a variety of test questions here, practice questions that won't be evaluated. Now for the forecasting, we'll turn off submit prediction. We'll turn off forecasting. So we're not going to publish them as comments. We're not going to submit to the tournament, but we are going to get news. And so we're going to set our API keys. And then for each question in this list of questions, let's just do one question here. We will just look at, for example, the second question. So something like this, and run that. So the question is, will OpenAI's O1 model remain the top LLM in all categories of Chatbot Arena on the end of the year? And it resolves to yes if the model has the same or higher rank than all the other models. So you can see now we're fetching all these news articles. So here are the news articles being injected. There's quite a lot because there's 5 recent and 20 historical. And then we have some input from Perplexity. So this is the response from Perplexity that's been injected. And now we have the day's date. And now we have the prompt that's asking us to focus on these 4 things. And that wraps up the full prompt. And here we have the response. So it's predicting 85%. Don't be fooled. This number is not being printed first. It's being extracted, printed, and then we're printing the response. But you get the chain of thought first. So here is the chain of thought. And then it finishes off with the probability here of 85%. And you can see it is going through the request. It's talking about the time left till outcome if nothing changed, if there was a quarter of time, if there was 4x the time. And then it's going through the rationale. And finally, it's giving a percentage prediction, which we're pulling out and then using to make a prediction. So that's a quick overview of how you can submit to the Metaculus tournament. Note that there are going to be questions that are not just binary. There will be multiple choice or continuous value questions. That's something that will probably be added to the Metaculus notebook, so it'll make submission a little bit easier. But hopefully you can see here roughly how you could enter and some different techniques that might improve your score. And that's it for my overview of using LLMs for doing predictions. I'll put a link below to the Metaculus competition and also to the Collab notebook if you want to get started. If you do want to enter, you'll need to initially have a kind of scheduler that automatically submits every day for the new questions that come out, because all the questions are not released at the start. They're released on kind of a rolling basis. And so you need to either set up a cron job on your laptop or maybe a Raspberry Pi at home. That's how I've done it, or some server or online service. You can potentially use GitHub as well in order to schedule some of your submissions. All right, folks, let me know any questions below in the comments. Cheers.